Okay, we're still talking about circles. We're in section 10-3, and we're going to talk about arcs and chords. Okay, so we already know what both of those things are. A chord is a segment that goes across a circle, and an arc is part of the circumference, or the edge around a circle. So we'll start out by saying that two arcs are congruent if and only if their corresponding segments are congruent. Okay, so we're going to draw pictures of what that looks like, obviously. So here we have a circle, and in that circle we're going to put two chords. So here's one, and then here's the other one, and we're going to try to make them the same length. So do your best to make them look like they're similar, or actually like they're congruent. And then we're going to label. So this will be A and B. This will be C and D. These two arcs are congruent. Okay, so what all this writing means, two arcs are congruent if and only if their corresponding segments are congruent, is that AB being congruent to CD means that segment AB is congruent to segment CD. Okay, so it's not anything super exciting, but it's something you have to recognize when you're doing problems. And this works both ways. So if the segments are congruent, then the arcs are congruent. If the arcs are congruent, the segments are congruent. And that also means that the measure is equal to. So if the measures are equal, which is basically the same thing, it's just, remember, congruent is about more about the shape, and the measure is more about the length. So the length of AB is equal to the length of CD. All right, so that is our first little fact about arcs and chords. We're going to have two more and then one example problem. So our second fact is that if a diameter, and anything we say about a diameter is pretty much true for a radius too, because a radius is just half of a diameter. So if a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc. Okay, so we're going to obviously do another picture of that. So here we have our circle, and our little fact said that if a diameter, so we're going to add in a diameter. So this will be circle C. It says if a diameter is perpendicular to a chord. So we need to add in a chord. So there's our diameter, perpendicular to a chord, and we'll go ahead and mark that it's perpendicular. So if the diameter is perpendicular to a chord, then it bisects the chord. So whenever you see this happen, we'll go ahead and label all these little points, A, D, B, and this one will be E. Whenever you see that happen, it means that, and you're not going to be able to do this as fast as I am, but that's okay. It bisects the chord, and it bisects the segment. Okay, so anytime that the radius or the diameter is perpendicular to the chord. It bisects the chord, so AE is congruent to EB, and it bisects the arc, so AD is congruent to DB. Okay, so not real tricky, just something, again, we have to recognize it. Okay, our last fact is that in a circle, two chords are congruent if and only if they are equidistant from the center. Okay, so a lot of big words in there, but nothing really exciting again either. It's just going to be kind of an idea or a picture that you've got to be able to see, you got to be able to recognize it, and then apply this fact about it. So we're going to put our center, and we're going to put two chords, and we're going to try to make them the same distance from the center. So we'll put one here, and we'll put one right there. And now the idea is that if the two chords are equidistant from the center, and we know that when we measure distances, we always measure perpendicular. So that is going to be perpendicular, and we want that distance to be perpendicular. And so if they're equidistant, that means these two purple line segments are the same length. So if that's true, and we see that, then AB is congruent to CD, and because of our first little fact that we learned, arc AB is congruent to arc CD. Okay, so not a big deal. I'm going to do one example problem just so you can get an idea of how you can use these three facts. So we're going to draw a circle and put in the diameter. So this will be circle C, and we'll call the diameter FE. Then we're going to add in a chord, and we're going to say that the two pieces of the chord are congruent. So this is equal to this. So this will be A, this will be B, and our little intersection where they cross right here will be D. And the only fact that we're going to know is that AB equals 12, FE equals 20, and our instructions are to find the distance from C to D. Okay, so the best strategy for these kind of problems is to redraw the picture and then go around and label the things that you know. So AB is equal to 12. So I could put a 12 on here, but what would probably be smarter is, since I see that these are marked the same, is to say that this is 6 and this is 6, right? Because that's how the 12 would really be used. And then FE is 20. So from F to E is 20. But that also means that from F to C is 10, right? And so when you first look at this picture, it may not be clear how to do it. There's nothing that jumps out and says, oh, well, that's obvious. But something that you may not see is that the distance from C to A, so this distance is also a radius of the circle. So that distance right there is also 10. And if we look right in the center here, we hopefully see that we have a right triangle. And the reason I know it's a right triangle is because my rule farther up said that if a diameter is perpendicular to a chord, then it bisects the chord. So what I really have here is this right triangle that's 6 tall, the hypotenuse of 10, and I'm trying to find this distance, which from my picture is CD. So to find CD, x squared plus 6 squared equals 10 squared. So x squared equals, this is 100 minus 36, so x squared equals 64. X equals square root of 64, which is 8. And so CD equals 8. Okay, if they had asked us for how long DE is right here, well, we could have found that. That's 2, because 8 plus 2 makes the 10 we needed. So not really that hard. Just uses a few little random facts to help you solve the problem. All right, see you tomorrow.